So solve each equation for the variable that's in that equation and check your solutions if possible. So let's start with the first one. It's 8a plus another a minus 3 equals 6a minus 2a minus 3. So I rewrote this down here. Let me make it a little bit larger. So when I combine on the left-hand side 8a and an additional a, that gives me 9a, right, minus 3. And that equals 6a's minus 2a's would be a 4a, and then also minus 3. Now what's nice about this is I can see each side has a 3. I'm just going to add 3 to each side. When I do that, I get that 9a equals 4a. Now a lot of times people are like, hey, those are different. That can't work. Well, let's just hold on. If I take away 4a from each side, right, I get 5a on the one side, and on the other side I get 0. So, and then if I divide both sides by 5, I do see that a has to be 0. Now I saw it sooner, but it turns out that that's the value that makes this true, right? When a is 5, this equation is satisfied that this is true. This equality is true. So let's check that, right? In order to check it, I'm just going to plug that value in, right? So 8 times 0 plus a another 0 and then minus 3. So that's the left-hand side. And over on the right-hand side, I need to see if it's the same. On the right-hand side, I've got 6 times 0, oops, and then minus 2 times 0 minus 3. Well, you can see 0 is 0. 0 plus 0 is 0, so I end up with negative 3 on this side. And this is 0, and this is 0, and I get with negative 3 on this side. So you can see when a is 0, it does indeed make the left-hand side and the right-hand side the same. It makes them both negative 3. So a is my solution. There's actually quite a few ways that you could look at part B. And I don't want to get into the possibility of division by 0 here. So what I'm going to do is go ahead and multiply the left and the right hand side out. So if you look carefully, right, this is m plus 2 times an m plus 3. So I'm going to use a generic area model to find that product, right? M plus 2 and then an m and a negative 3. When I do that, I have an m squared. Below that, I would have negative 3m. To the right of that would be a negative 6, and up above I would have 2m. So if I expand that out, right, there's two terms that I can combine, the negative 3m and the positive 2m. What I get here is I get m squared and then minus a single m. That's negative 3m plus 2m and then minus 6. So that's my left-hand side. On my right-hand side, if I do that, I do notice that my middle term drops out. So look at this. I've got an m and a plus 2 and an m and a minus 2. This gives me m squared 2m, negative 2m, and then negative 4. So this negative 2m and positive 2m, right, combine to give me 0. So I end up getting over here m squared minus 4. Now, each side of this equation has an m squared, so I'm going to take away m squared from each side. The equation then becomes the opposite of m minus 6 equals negative 4. So I guess now what I'm going to do is I'm going to go ahead and add 6 to both sides. You got to be real careful here. If I add 6 to the left-hand side, I just have the negative m. And on the right-hand side, when I add 6, I have that equals positive 2. Now, if negative m is 2, right, I can multiply both sides by negative 1. M has to be negative 2. So here's the value that I think m is. I believe m is negative 2. Now, if I plug that back in to the original equation as a check, let's take a look at it. So it was m plus 2, so this is going to be a negative 2 plus 2. Okay, and then that's going to be an m, which is negative 2 plus 3. So if I look at this side alone, I have 0 times the number 1, which is 0. So on the left-hand side, right, this whole left-hand side ends up being just 0 when m is negative 2. And on the right hand side, when I plug -2 in there, I get actually -2 plus 2, which is again 0. And then I get a -2 minus 2, which is -4. So I end up getting 0 times -4, which is 0. So when m is -2, the left-hand side becomes 0 and the right-hand side becomes 0. So it looks certainly like a solution. You know, it certainly makes this a true statement, right? When m is -2, certainly the left and the right-hand side of that equation do both become 0. For part C, if I look at this, the first thing I think of is fraction busters. So I'm going to choose to multiply both sides of this equation by 2. Right, when I multiply it on the left-hand side, the first term times 2, I get 2x over 2, which is simply x. And then 2 times 1 is plus 2. And on the other side, that equals 6 times 2, or 12. And if I take away 2 from both sides, we get that x is 10. If I want to do the check, right, so here's my check. If x equals 10, the question is, are the left and the right hand side the same? On one side, I've got 10 over 2 plus 1, which is 5 plus 1. And on the other side, it was 6. So yeah, 6 is the same as 6. So when x is 10, it does indeed make both the left and the right hand side 6, which means it makes them equal to each other. So 10 is the value that produces truth. And then for our final equation, if I look at this, I've got both sides have a t squared, so I'm going to take away t squared from each side. When I do that, I'm left with 4t minus 2, and that equals 6. If I add 2 to both sides, I get that 4 times t is 8. And if I divide both sides by 4, we get that t is 2. So that, I believe, is what t is. Let's check that. So check. And we're saying, hey, if t equals 2, does it make the left and right hand side the same? So if I put 2 in the left hand side, I have 4 times 2 minus 2 plus a 2 squared. 4 times 2 is 8 minus 2 plus another 4. 8 minus 2 is 6, and 6 plus 4 is 10. So on the other side, let's put 2 in there. So I get 6 plus 2 squared, 2 squared, which is 6 plus 4, which is 10. So I can see now that, yeah, when I do indeed put 2 into both the left and the right hand side, it does give me 10. So 2 is indeed the t is 2 is the solution, and it produces 10 for both the left hand side and the right hand side.